Hi, my name's Con Winter. We use our hands for lots of things. We use it for building things with hammers. We use it for painting things with our paintbrushes. We use them for carrying things in our buckets full of paint and water. Our hands are very important. Our hands also get a lot of dirty. Mine especially, I can attest to. Heck, my hands are pretty much dripping with dirt. They're very, very dirty. Even water doesn't help all that much. My water, there's so much dirt that the water doesn't get it all off. It doesn't work. See, I need something that's just going to upgrade the water. Something that's going to give it a +1. Something that might even make water more wet. So I made soap. SOAP. Soap sometimes comes in this little pink bar. It's very nice. Heck, it's pink. If something's pink, it's very nice. It has even these little sparkles on top. All around it. It makes things so clean. It just makes them very sparkly. Soap adds on to water. It gives it a little +1 boost. It even makes water wetter. It makes it like there's even more water there. It just makes it that much powerful. Soap, it goes into the water and it takes little dirt droplets like that one. It comes around it and it takes it in the water and it pushes it out. Next, we're going to talk about structure of soap. So, soap starts out with a carbon atom and 3 hydrogen atoms bonded together. Then, it's going to be made up of an n number of carbon and 2 dihydrogen atoms in a long line. And at the end of that long line is going to be a carbon and 2 more oxygen atoms that are going to create a negative bond and an ionic bond with a sodium atom. Now, the structure is actually going to look like this little diagram here. Those circles are the carbon atoms. The blue ones are the hydrogen atoms. So it's going to look at this long tail thing here. And at the end, there's going to be this carbon atom. And it's going to be bonded with these oxygen atoms. And those oxygen atoms are going to actually create a negative charge. That charge is going to bond with a sodium atom. And that negative and positive side will create a charge, and that's going to be called the head. It's going to have an ionic bond, and it's going to have a polarity. I mean, it's going to have a positive side and a negative side. It's kind of like a magnet. Now, the other side, it is non-polar. It does not have a negative or a positive side, and that's actually going to be called the tail. So there's the end with CH3, and the middle made up of CH2s. At the end, you have the CO2 and the sodium right at the head of the head. The last thing I want to touch on is the tail is something called hydrophobic. It does not like water. Well, the head is hydrophilic. It likes water. It wants to go towards it whenever it can. This makes it so when it's on the surface of water, the tail is always going to go away from the water as much as possible, where the head is going to go towards the water and farther into water as it can. And that makes it so on the surface of water, the structure is going to look exactly like that, where they're all in a row. Now, this makes it perfect for taking oil and grime off of things like your hand. Here's a hand with some oil on it. Now, around this oil, there's going to be some soap molecules, like you would when you're washing your hands with soap. They're kind of adrift right now, but as time goes on, let me just move this quick, we're going to see that those molecules that were floating around are going to start being repelled towards that oil, because of that part that loves water and part that doesn't. The part that doesn't like water is going to be going towards the oil or grime. And eventually, those are actually going to bond with it so much that it's going to start lifting that oil or grime off of the hand or the surface it's on. It's going to start bringing it up into the water. And again, the head is wanting to go into the water while the tail isn't. That keeps it attached to the grime while keeping the soap atoms around it. Now, eventually, the oil is going to be completely encapsulated by these soap molecules, and it's going to be perfectly stayed up there, and it's going to be totally off the hand. Soap gives water an upgrade. It makes it wetter than wet. It gives it more power than it normally would. It takes away oil off of the hand or surface by bringing it up and making a bubble around it and taking it off. All because of this unique structure where it's half ionic and with a polarity and half non-ionic. Half of it loves water, half it doesn't, and it all hates dirt. Soap.